Hello guys, welcome in this session. Today I am going to discuss about the deployment of 5G architectures. So in this video, uh, I have discussed the two types of architectures in the 5G communication system. First one is the standalone architecture and other one is a non-standalone architecture. So as you see in the in this figure below, there are the two types of core networks are used here. First is the LTE EPC cloud network and other one is the 5G core network. LTE is a long-term evolved packet core network. This is the cloud network for 4G communication system, and this is the 5G data network. And as in the form of options, there are the total 8 options, and these are the interfaces that are used to connect the base station to the cloud. Here this is the LTE RAN. This is long-term evaluation radio access network. This is a 4G base stations here, and that is connected with the LTE 4G data network, and this is also connected with the 5G core data network. And other one is the 4G network, that is microwaves 4G base station, and under this coverage here use the 5G new radio base station. And same as opposite used in the 5G core network. In the 5G core network, under here use the 5G base station, and under the coverage of 5G base station use the LTE radio access network 4G base station. And this is here used only single 5G new radio base stations here. And there are the 8 options, total 8 interfaces that are used to determine the connections between the base station to the data network. So first one is the option 1 here, or interface 1, that is 4G base station is connected with the 4G data network, and that is option 5 is the interface between 4G base station is connected with the 5G data network. And also for second, here is the option 3. This is the 4G base station, and via option 3 it is connected with the 4G data network here. And option 2 here, that is the 5G base station is connected with 5G core network, and also 5G base stations is connected with the 4G base station via option 6 or option 6 interface. And same as the option 7, that is the 4G base station, and under the 4G base station there is a 5G base station that is connected with the 5G core network via UPF. And here this is the 5G base station coverage, and under the 5G base station coverage deploy the 4G base station, but this base station will access the 5G data services. And this is take the option 4 to connect with 5G core, and option 8 is used to connect these base stations to the LTE or 4G data network. This all process in this system architecture. And as you see in these type of crosses in the option 8 and option 6, so these option 8 and option 6 are removed by the third generation partnership project, because this base station is 4G base station and deployed under the services of 5G base station. So this base station is totally changed, and this handled by the 5G core network, and this will not get the services from the 4G data network here. And here the option 8, this 5G new radio base station, and this will totally depend upon the 5G core network, not depend upon the 4G data server. So that is why the option 8 and option 6 are removed in the 3GPP. And what is NSA and SA, non-standalone architecture and standalone architecture? First of all, what is non-standalone architecture? Non-standalone architecture is the architecture where the 5G or a new radio base station is deployed under the coverage of the 4G base station. Here, this is a non-standalone architecture, and here where only the 5G base station is deployed, single base station is deployed and connected with the 5G core. This is called the standalone architecture. So these are the two types of architectures here. I also has discussed below these lines. Blue lines are denoted the LTE EPC connections. All the 4G connections are denoted by the blue line, and red lines denoted the 5G connections, new radio connections, new radio interfaces, and these are the 4G interfaces. And option 6 and option 8 are removed, that I have already told you by 3GPP. And option 2, here the option 2, this is the option 2. Option 2 has only standalone and new radio. It has a new radio base station. This is only standalone is the option 2. This. And non-standalone NSA, where the 5G radio access network is conjunction with existing long-term evaluation radio access network or 4G network. And high speed connectivity to the, it gives the high speed connectivity to the consumers for 4G. Next one is the standalone. The standalone is launched new 5G services like smart cities, smart factories, etc. And here use the slicing. Slicing is the technology that used to separate the services for different users for handle the traffic control. And here slicing enable to separate the services for the users, and using the cloud native microservices, use the private cloud, public cloud, etc. for different services. Big cloud for handle the different users, use the different services for different users to handle the traffic in the system. And next one is here is in the figure below. Here is this is the user, and this is the new radio base station, the 5G base station. And there are the two data centers. First is the local data center, and other one is a regional data center. Local data center is their data center that is near to the 5G base station, and maximum time the 5G is communication is possible between the this base station and local data center. And the regional data center, that is in the in other region, and these 5G base stations also communicate with that particular regional data center. But when the communication possible between the local data center and base station, and as well as base station with the regional data center, there is a latencies changes between both them. And here the local data center that utilize the different data services for the different users. Here also regional data center also utilize the different services for different data user, but in the gateway time. And due to these data centers, latencies changed. Whenever this base station communicate with this, there is latency is small. But when the this base station is communicating with this, and in that case the chances of latency is large, increasing. So all this in this lecture. I hope you like this video. If you really understand from this video, please like, share and comment. Thank you.